Hello everyone, today I'm going to present my work on MHF4U Unit 4 mid-unit assignment. So let's get started. The first question asks about the trigonometric equation that models the information of this temperature change. Here we could see that the formula we have to use is this one. F of x equal to a cos k into x minus d plus c. So this is the new formula for this kind of trigonometric equation. So here I make a little notes here that says the amplitude is maximum value, the subtracting the maximum and minimum and divided by 2, and the constant is k is equal to 2 pi by period, and vertical translation is c is equal to maximum value plus minimum value by 2, and the horizontal translation is we have to determine the curve. So here, as we have started here, the maximum value, by looking at this table, we can see that the maximum value is 21 degrees Celsius. The minimum is minus 24 degrees Celsius. And we then substitute the value into this formula and we get the amplitude, that is 22.5. And then next up we have periods. And here we can make a little change the formula, and we put this period 12 to here, and the value of k is pi by 6. So by determining the shape of the curve, we can see here that the horizontal translation would be d is equal to 0, and vertical translation would be c is equal to by here maximum plus minimum by 2. So the value would be minus 3 by 2. Here we can see that the horizontal translation is 0 because we can say here that by looking at this graph, there's no either shift to the left or either shift to the right. Okay. So by substituting this value, we get the final equation, that is 45 by 2 cos pi by 6x minus 3 by 2. This is number 1. And moving on to number 2, we get the first question is that sketch the graph to show how a rider's height above the ground varies with time as the ferry wheel makes a rotation. Assume the person starts the ride at the lowest point on the wheel. So as you can see here, we could simply say here, assuming the person is here, starting from here, we get this rotates up. So after 24 hours, it completes 1 revolution. So we can assume that the 1/4 of the, so to complete the quarter of the revolution, it takes about 6 seconds, of course. So here, in looking at this diameter, we get the radius that is 5 meters. So we can build these graphs here. That says, since the time is 0, the height would be 1 because the distance between the wheel and the ground is 1 meter, already 1 meter. So the initial height would be 1. And as it rotates here, at 6, it would be 6 because this is 1 meter and the radius would be 5 meters. So the total height would be 6 meters. And moving on to 12 seconds, we get 1 meter plus diameter 10 meters, so we get 11 meters. And it then recycles up, and the 18 would be 6 and 24 would be 1 respectively. So after that, we build a graph, draw graphs, and then we get the maximum and minimum height. That is, minimum would be 1 meter, maximum would be 11 meters, and the amplitude, look at this, would be 5, of course. Here, the period would be, by looking at this here, the periods would be 24. At this 24, this would be pi by 12. So by determining the graph's shape, there's no either, as I have said, there's no either shift to the right or shift to the left. So it would be 0, and the vertical translation would be to put this, and add this and this, and divide it by 2. So we get 6. And then we have this kind of little tricky one. As the graphs is in, of course, along reflected in the x-axis, the value of A, as we have noted, would be negative. So the value of A instead we find here would be not positive 5, but negative 5 in this equation. So we get the final equation of minus 5 cos pi by 2 t plus 6. So this is the final equation. So the C would be, check the accuracy of your equation by using t is equal to 12 seconds. So that means we have to put t equal to 12 into this equation, and we get the final answer of 11. So that's all about my solution on 2. When moving on to number 3, we get here number A. There is the maximum height here. This would be 17.3 and 821. And minimum height would be 4.5 meter at 208. So here, by looking at this, we could see here that the amplitude would be maximum minus minimum by 2. We get here 6.4. The amplitude would be 6.4. And the period is measured in 24-hour clocks. So we have to multiply it with 2. Here we get the answer 12.44, and the periods would be 12.44 and 2 pi by 12.44, and we get 0.505. And the horizontal translation, as we have seen it here, is that it varies from a low of 4.5 or 17.3. So there, which means that there is indeed the horizontal translation, and this is going to be in the form of time. So here, the graphs tells us about the time. So the graphs possibly shifts to the right. So by looking at this, we could convert it into hours, into the unit of hours, and then the vertical translation, and we can find the vertical translation, that would be 10.9. So by using that, my aforementioned equation, by substitution here, we get the final equation of 6.4 cos 0.0505 t or 0.05 into t minus 8.35 plus 10.9. So the time here, it says like in question C, we see determine the height of the tire relative to the pier at 11:30. So we need to see here is that we first convert it into 11:30 into 11.5 hour, and then we substitute the value into this equation, and we get the answer, this 10.8 meter. So the last question is that we have to equate it with h of t into 12, and this is the process here. We just do it with do a little bit of calculation, and the final answer is t is equal to 11.12. So using these values back, we can see here that I draw a table. Here I use these aforementioned. I will show you. Here, this 821 would be 8.35, and 221 would be 208. So, and then 11.12 would be 11.12 and 11.5. 11.12 is already 12, and we have already seen it before, as stated before. And then the values are calculated using calculators, of course. So then I draw the graphs here, and as I said, that it needs at least 12 meters to dock the ship. So the period would be very limited. So this section of this graph would be the period of docking. By judging the appearance of the graph, I can conclude that it can dock between 5.6 hours to 11.12 hours. So here from the graphs, since the depth of 12 meters needed to dock at the pier, by converting into the minutes, we could see here that the boats could dock between the period of